Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 7 in the Business Logic Vulnerabilities module titled Weak Isolation on Dual Use Endpoint. Alright, before we continue with the video, I'd like to announce that this video is part of a course that I offer on my academy. Now you might be wondering, why would I buy a course that is made available for free on YouTube? Well, there are 4 reasons why you might want to do that. Number 1 is that you gain early access to recorded material. As soon as I record new videos, I make them available through my course right away, whereas on YouTube, they'll only be released on a weekly schedule. Reason number 2 is that you gain access to a Discord channel where you can ask questions. The Discord channel is divided into topics that we cover in the course, and if you run into any issues, you get to ask questions about anything related to the course material. Reason number 3 is that you no longer have to deal with YouTube ads or sponsor messages. And last but not least, reason number 4 is you get to support me. Any revenue generated from this course will go back into maintaining the academy and creating more videos and courses that will be made available for free on my YouTube channel. So if you're interested in buying the course, make sure to check out the link in the description. And that is it. Let's go back to our video. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, select all labs, and then do a search for Business Logic Vulnerabilities, and go to lab number 7 titled Weak Isolation on Dual Use Endpoint. Alright, let's get started. This lab makes a flawed assumption about the user's privilege level based on their input. As a result, you can exploit the logic of its account management features to gain access to arbitrary users' accounts. To solve the lab, access the administrator account and delete Carlos. You can log into your own account using the following credentials. So the target goal over here is to exploit some kind of logic vulnerability in the way that you can manage your account and then escalate our privileges to administrator and delete the Carlos user. All right, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed through my Burp proxy. Okay, the first thing we're going to do is click on my account and log in using the credentials that we were given. So the password was Peter, hit login. Now notice over here you have the ability to change the email address, but you also have the ability to change the password. So let's test the change email address functionality first. So let's say test.test.ca. Click on update email. It's a post request. And if we look over here, it just takes in the email address of the user and then it changes it. So it doesn't look to me this is vulnerable, which means the vulnerability must exist in the change password functionality. So that takes in a username and then you have to put in the current password, which is Peter. And then let's say the new password is test and we confirm the new password, which is test again. So let's change password and look at the post request that it performs. Okay. Let's send this to repeater and look at it. So it's to the endpoint /my account/change password. And if we go down over here, you could see it takes in a CSRF token. It takes in the username of the user you want to change the password to. It takes in the current password and then the new password and then the new password again. Now, the first thing that I'm going to try is change this to administrator. This will likely not work. But if there is some kind of flaw in the backend where it allows you to change any user's account and depends on the username, not based on this specific parameter, but on this user that is tied to the session ID, then you should be able to enter the current password of the user that is tied to the session ID. However, change it for this username over here. It's very unlikely that this will work, but let's test it out. Hit send and let's render over here. It says current password is incorrect and your username is administrator. So this is definitely not validated. We could put any username that we want. However, in order to be able to change the administrator's password, we need to know the current password. And so it doesn't really matter this way. I could just log into the administrator's account if I actually had the current password, which I don't. So the next thing that I'm going to try is see if it actually enforces that you have to have the current password. So let's remove this and hit send. It says user does not exist. So that's interesting. Maybe I'm spelling that correctly. So let's say administrator right over here. I'm missing an I. Hit send. And it says the password changed successfully. So my guess is it actually changed it for the administrator password because it didn't have any enforcement on the fact that you had to put in the new password. It also didn't verify that the username over here has to be the same username that is tied to this session ID. And so there's two vulnerabilities over here that allow us to escalate our privileges to admin. So let's go to my account and then log out and then log in using the administrator's account. So administrator, and we change the password to test, hit login. And here we go. It allows us to log in as the administrator user. If we go to admin panel, we could delete the Carlos user. And we get the congratulations, you solved the lab message. All right, so we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. All right, the first thing that we're going to do is import the libraries that we need. So import requests, import sys, import URL lib3, and then from BS4, import beautiful soup, and then import the regex library. Next, we're going to disable and secure request warnings. So disable warnings, URL lib3.exceptions.insecure request warning. And then we're going to set our proxy settings so that all my requests are sent to Burp just in case I need to debug my script. So all HTTP traffic should be sent to HTTP 127.0.0.1 port 8080. Same goes for all HTTPS traffic. It should be sent to HTTP 127.0.0.1 port 8080. And then we'll define our main method. So we'll say def main. If the length of the command line arguments is not equal to 2, that means the user ran it incorrectly. And so we'll print the usage instructions. So usage is the name of the program and then URL. And we take the name of the program from the command line argument. So sys.argv 0. And then we also print example instructions. So we'll say an example URL, www.example.com, and it also takes the name of the program from the command line argument, so argv 0. And then we exit the program because the user ran it incorrectly. Now let's assume the user did run the program correctly. The first thing that we're going to do is initialize our sessions object. And then we're going to create a variable called URL, and we'll take the command line argument, so the URL that we entered in the command line argument, and save it in the variable URL. And then we're going to call a function called change administrator password that takes in the session object and the URL. Now I'm noticing over here I missed calling the main function. So if name is equal to main, then call the main function. All right, this looks good. So if the user runs the program correctly, it'll create the session object and the URL variable, and then it'll call this function over here, which is a custom function that we need to implement. So we'll say def change administrator password, takes in the session object and the URL. The first thing that we need to do is log in as the regular user that we were given, and then from there try to change the administrator password. So to log in, we're going to go to proxy and look at the login request. So we're looking for a post request. Let's make this a little bit smaller. Here we go. So it's a post request to the /login endpoint, and it takes in 3 parameters: CSRF, username, and password. Now, username and password, we already have. The CSRF token, though, we need to extract from the /login request. So if you do a search right over here, you could see this is the CSRF token. So the first thing that we need to do is extract or retrieve the CSRF token. And to do that, we need to create a variable called login URL, and that would be the URL plus the /login endpoint. And then we're going to create a variable called CSRF token, and that would be equal to the return value of the function get CSRF token, session object, and then the login URL. So we're going to create a function that does this for us because we'll likely need to retrieve the CSRF token for multiple requests. So I'm going to say rest of code here, and then create my get CSRF token function. So that would be def get CSRF token, takes in the session object and a URL. And then from there, to get it, it's simply making the get request. So s.get to the URL that we gave it. We're going to set verify to be equal to false because I don't want to verify TLS certificates, and proxies to be equal to proxies because I want the request to be sent to Burp. And then I'm going to parse the response using the beautiful soup library. So the response is r.text, and I'm going to set the parser to html.parser. And then from there, I'm going to create a variable called CSRF. And in that variable, I'm going to use the beautiful soup library to find it. So you can see over here, the CSRF token is in an input element that has the name CSRF, and the CSRF token is in the value attribute. And so to extract it, we're going to say, look for the input element that has a name CSRF, and then I want the content of the value attribute. So that'll extract it, and then we're going to return it. Okay, this looks good. So over here, it extracts it and it saves it in the CSRF token variable. The next thing that I'm going to do is log in as the user that we were given. So log in as the user that we were given. So we'll print a statement saying that we're logging in as the user, and to log in I need to take in the parameters of that request. So we'll say data login is equal to, if we go right over here, it takes in 3 parameters: CSRF, username, and password. So we'll start off with the CSRF1, which we just extracted, so it's equal to CSRF token. The username we were given, and the password we were also given, so that was Peter. And then we just perform the request. So we'll say r is equal to s.post, takes in the login URL, data is equal to data login, which we just created, verify is equal to false because I don't want to verify TLS certificates, and proxies is equal to proxies because I want my request to be sent to Burp. Next, I'm going to save the response in res. So r.text is equal to res. And I'm going to validate that I successfully logged in. So I'll say if logout string is in res, that means I successfully logged in as the user that we were given. Otherwise, I'm going to print could not log in as user, and then I'll exit the program because you need to be able to log in order to exploit this vulnerability. All right, this looks good. Now assume that we logged in. The next step is to change the password of the administrator user. And so we'll print another statement saying that we're changing the password of the administrator user. And to do that, we need to perform the request that is in repeater. So it's a post request to this endpoint right over here. So let's copy that and save that in a URL variable. So we'll say change password URL is equal to this right over here. And then we'll say CSRF token. So if we look over here, you could see it takes in a few parameters, the CSRF token, the username, the new password, and then the new password too. So for the CSRF token, we need to extract it again. And so we'll just call our function CSRF get CSRF token to extract it. So that takes in, again, the session object. It also takes in the URL of the application plus the path / my account, because that's where the CSRF token is extracted from. Okay, this looks good. And then we need to create a variable called data change password. And that takes in first the CSRF token. So CSRF, and it's saved in CSRF token, and then it takes in username, which is equal to administrator, and then password, and a new password, 1, which is equal to test, and new password 2, which is also equal to test. All right, this looks good. Let's keep the quotes consistent. Next, we just perform the request. So s.post, change password URL, data is equal to data change password, verify is equal to false, and proxies is equal to proxies. And then we'll save the response in a variable called res. So r.text is equal to res. Now we need to verify that the password change was successful. So we're going to say if you find the string in the response, so if password changed successfully, is in res, then print successfully changed the administrator password. Otherwise, print could not change the administrator password, and exit the program because our exploit failed. Okay, so now that we've successfully changed the administrator's password, we need to log in as the administrator. And so I'm going to create another session variable over here. Let's say s2 is equal to request.session. And I'm going to call a new function that we need to create called delete Carlos, and it takes in the session object and the URL. All right, so this function is responsible for deleting the Carlos user. So we'll add it over here, def delete Carlos, and it takes in the session object and the URL. Okay, so this is going to be really similar to the previous function. So we're just going to reuse some of the code. There's probably a more efficient way to write this up. Okay, So first thing is we need to extract the CSRF token again to log in, but in this case, we're logging in as the administrator user. So username was also administrator, and the password that we selected for the administrator user was test. And from there, if we see the logout button, that means we successfully logged in as the administrator user. And if we don't see the logout button, that means we didn't successfully log in as the administrator user. All right, let's assume we logged in as the administrator user. The next thing that we need to do is delete the Carlos user. So delete Carlos user. To do that, we'll have to define the URL that is responsible for that functionality. So delete Carlos URL, and that's equal to URL plus the endpoint right over here. So if we go to proxy and we look for the endpoint to delete the Carlos user, it was this one. And it's a GET request, so it's a little bit easier for us to perform this request. We don't need any parameters in the body of the request. So over here, we just perform the request. So R is equal to s.get. And it takes in the delete Carlos URL, and then verify is set to false. And proxies is equal to proxies. And then we're going to say if congratulations is in r.text, then print successfully deleted the Carlos user. Otherwise, we're going to print could not delete the Carlos user, and we'll exit the program. So sys.exit -1. All right, this looks good. This was a very long script. So let's open a new instance of our lab because this one timed out. And while that opens up, let's review our script. So the first thing that we do is call the function to change the administrator password. In there, we log in as the regular user, and then we exploit the vulnerability to change the password of the administrator user. And then we call the function delete Carlos, which logs in as the administrator user with the new password that we just set, and then deletes the Carlos user. Hopefully there's no errors in my script. So let's go to terminal, new terminal, and run it. So Python 3, business logic flaw 07, and copy the URL, paste it in here, and remove the slash. So far so good. And we do get an error. So that was on line number 84. This looks fine, so it must be line number 36 that is the issue. So let's go to 36. Change password URL. Oh, we're missing URL plus the path. All right, hopefully this is the only error. So far so good. And here we go. It says, congratulations, you solved the exercise. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at a more complex case of business logic vulnerability. If you liked the video, hit the subscribe and share button so that the video reaches a wider audience. Also, make sure to check out my course if you're interested in seeing more videos like this one. Thank you, and see you in the next video.